To download the software, go to the Federal Highways website and you can see that they've got the version available for download right here.
This culvert is a box culvert. Rather than being a circular pipe, this one is 1.5 meters by 1.5 meters. We're making the culvert out of concrete. It has a certain slope, 0.007, and we know the length of it. Now if you think about what HY8 is going to be asking you for, it asks you for the inlet station and the outlet station. Well, we don't have that defined here. So you sort of have to figure that out on your own. What you could say is you could say the inlet station for the culvert is 0 and the outlet station is 40. Because what we know is that we want to simulate a culvert that's 40 meters long. You'll remember that HY8 also asks you to define the channel elevation and the invert elevations at the opening and the exit of the culvert. We don't have that, so we have to simulate some elevation. Like what we could say is, just by definition, let's call the invert elevation here 100 meters, and then downstream it's going to have to be 100 minus 40 times 0.007, because this S, the slope of the culvert, tells us how much elevation is being lost for each meter of culvert length. Okay, so once we define the geometry of the culvert, we want to do some analysis here. We want to find out what flow rate will cause the headwater depth to be 2 meters when we have a channel width equal to 5 meters. We're going to do rectangular channels here. And then in part B, if we change the channel width, then what tailwater depth will give us 2 meters for a certain flow rate. Okay, so this is a little bit more ill-defined than the first problem was, where we were spoon-feeding all of the different fields that we needed to fill in. I'm going to do a new project. In this one, we're in SI units again, so I'm going to change from customary to SI. I'm going to click here and add a new culvert crossing. All right, so what flow rate do we want to even do for our range here? We don't know the flow rates. This is going to be something we have to play around with a little bit. So I'm just going to start from 0 flow to 10. And for the design flow, I'll have 9. And we may have to go back and change these flow rates to make sure that the calculations are being done within the range that we're interested in. All right, so we have a rectangular channel, and in part A, we want to have a channel width of 5 meters. So here, let's have a rectangular channel with a bottom width of 5 meters, and let's just assume that the channel slope is equal to the slope of the culvert. So I'm going to put 0.007, both for the channel and the slope of the culvert and the slope of the river downstream, 0.007. Okay, so 0.007. The end value of the channel, that same 0.05. And the channel invert elevation. So that is talking about this elevation here for the river. And so I'm going to have it be 100 minus 0.007 times 40. Because 100 is going to be this elevation, and this one is going to be lower. Anyone with a calculator tell me what that is? 99.72. Thank you. Okay, so we're defining here that 99.72 is the same as the outlet elevation for the culvert, 99.72. And then the inlet elevation is going to be 100. How long is the culvert? 40 meters. So I'm going to call the inlet station of the culvert 0 and the outlet station 40. And that is what tells the program how long the culvert is. Now, the roadway information. If we go back to this question, we don't really know anything about the road. But we don't want overtopping. And so I'm just going to put in some fake information for the roadway data, because I don't really care what happens once the overtopping occurs. I'm interested in what happens before the overtopping occurs. And so I'm just going to say that the crest length is 5 meters, the crest elevation. If this is 100, then I want to find out how much headwater is up to 2. I'm just going to call it like 103, the elevation of the roadway surface. Is there a question in the back? Did you have a question?
No, it was a different value.
Okay. Right, yeah. The channel is the river's end value, and then this end value is based on what it's made out of. The top width, let's just assume it's 2 lanes, and each lane is maybe 4 meters, and so we'll give it 8-meter top width. Again, the roadway data doesn't matter because we're trying to find out how this behaves before it overtops. All right, the example said it is rectangular, and the dimensions are 1.5 by 1.5 meters. Okay, so here, instead of circular, I'm going to select a concrete box, and it is 1,500 millimeters in span and 1,500 millimeters in rise. I'll leave the embedment depth, all these defaults here for the end value of concrete. I'll have it be straight culvert, and just leaving the if you change the material, I think it'll automatically change the end value. So if well, concrete's the only thing you can have for a concrete box, but for instance, if we had circular, we could change to corrugated steel, and it would give us a new end value, depending. Yeah, for an exam. Oh, the example. Oh, it does? Oh, okay. Oh, okay, yeah, thanks for noticing that. All right. Give me enough time and I'll figure it out. All right. So concrete box, we're going to do concrete. I'll change it from 0.12 to 0.13. That means maybe our contractor wasn't smoothing out the concrete as much as we would like. We're putting a little bit of a safety factor there. Okay. And we already specified the elevations and length of the concrete. So let's analyze and just see what's happening, because what we want to find out is what flow rate causes 2 meters of headwater. We don't know yet if we are doing the simulation at the right flow rate. So we will analyze the crossing. Headwater elevation of 2 meters. It looks like it's around between 5 and 6 cubic meters per second. So what I can do to nail things down even better is I'm going to have it redo the simulation over this range. I'm going to have the minimum flow be 5, and both the design and maximum flow be 6, and that way I'm forcing it to do those calculations and prepare that table just within this range. So I analyze the crossing again, and now here's 5 to 6, and so I wanted to find out, back to the question, what flow rate causes a headwater depth of 2 meters? Well, from this table, 2 meters of headwater is about 5.7 cubic meters per second. So I've answered the question. On the homework that I'm giving you, I ask you to take screenshots along the way. And maybe some of you have already done that before. Maybe that's a new thing for others. So let me just show you how to take a screenshot to prove that you did something. Like on this assignment, don't just write the answer of what you got, but I'd like to see like this, for example. And then you'd circle in, you know, like if the question was, what headwater, what's the flow rate for a headwater of 2 meters, then you'd maybe like circle this. So start up Microsoft Word, and then there's a button on the computer that says print screen on the keyboard, and if you just push that print screen button, then over here, once Word starts, we can paste, and it will be that, so here I'm just going to paste, it will be the picture like what was on screen before. And then you can crop it down here under the formatting tools. You can crop just the things that you want to have on the screen to answer the question that was being asked. You can use whatever you like. Yeah. Yes?
Can we export the data in Excel?
Yes.
I mean,
Mm-hmm. You know, exporting it to Excel is just an extra step, but if you prefer to do that, that's fine too. But it will give you, you can copy and paste it, like you can select the data and copy and paste it, and I think it will also, you can export to an Excel file directly. So, but the handout for the homework assignment, this assignment includes some calculations related to flumes so that you get a little bit of practice with that idea, which we did the example for earlier. And it also includes some questions related to, mostly this is a culvert assignment. But I give you an example on the handout of, you know, when I say that I want a screenshot, what it should look like. All right, so what was the second part of this example? We answered the first one. We found the flow rate that causes the headwater equal to 2. So now, the rectangular channel width, what channel width downstream will cause the tailwater to be 2 meters for that flow rate? So the flow rate that we found in part A was 5.7. Okay, so for 5.7, what is happening with the tailwater? So we can go here to the tailwater calculations. Here's this flow of 5.7. The depth downstream right now is just 0.898. So we could make that channel narrower than it is right now if we wanted to. So the question that's being asked by the example is, if you made the channel narrower, what would you have to have as the width of the channel so that the tailwater depth is 2 meters? So what we could do is go back into here, and the channel width right now is 5 meters. Well, what if it was 3? So let's view that. At 3 now the depth is up to 1.4. So we can make it even narrower because it increased the depth of water from having the channel narrower. So we could make that channel instead of 3 meters wide, let's see what happens if it is 1.5. At 1.5 meters of width and 5.2 cubic meters per second, now it looks like it's too much. And so it's just kind of like an optimization process where we could play around with the parameters that are described and find out through iteration what is the correct channel width.